So my name is Eddie Knight. I have a little baby. He's right there. He's 11 months old now. He's older than that. I am also the OSPO lead at Sonatype. Sonatype is a software supply chain security company. Prior to working at Sonatype, I was working inside Morgan Stanley. Prior to that, I was working inside Bank of America. So I've been part of FINOS for most of my career. Not literally. For several of the past years, I've been part of FINOS, and very, very excited to have been promoted to maintainer of the Compliant Financial Infrastructure project a couple years ago, and have had a lot of fun with that. I also, just to tell you a little bit more about myself, while I would do a lot of compliance work inside of the FINOS space, inside of CNCF, I do a lot of security work with their tag security, and we're currently running a security hygiene event for CNCF. That's we're going to be issuing awards to all of the projects that have improved their hygiene next week at KubeCon, so that's going to be really fun. Inside of OpenSSF, I'm a reviewer for the Security Insights specification, which is super, super fun. That's also kind of a bridge between compliance and security. So I'm very frequently operating in both of these spaces. I've written a few courses for the Linux Foundation's training and certification platform. And as you see, my little guy there, I deployed a fiction novel over the summer. And so that was pretty fun. But last thing for the intro, this was yesterday, and I can't help but share it. We were flying out here, and this guy, he's a lot bigger than in that last picture. This was him going through the airport. Total stranger there. He learned how to walk last Thursday, so we're very, very proud of this little guy. Thank you. Thank you. He was the most popular person. He got attention in Times Square, actually. People were like hollering at him, like, yeah, so that's quite a feat. Little cutie. So there you go. That's our introduction. Hopefully it gave everybody time, stragglers time to roll in here. Hey, you don't have somewhere else to be? Like, I'm sure there has to be something more interesting. No, come on in. Later on, we are going to do Who's That Surprise Guest? On the right side there, you might be able to guess that is somebody specific, but it's not James McLeod. If it was James McLeod, it would look like this. So I'm not going to tell you yet who these two surprise guests are, but we're going to roll these out here in just a minute. Before we do that, we're going to be talking about output. All day today, everybody's been talking about common cloud controls. It's in the title of this talk. It's in the title of a lot of different talks. It was in a keynote. If you haven't at least heard that term by this point in the day, or like after 2 o'clock, you've either just arrived or you've been sleeping. So I'm not going to talk a lot about what common cloud controls is, but I am going to do a quick TLDR to just brush us up on this particular topic of what the heck is going on with the CCC project. To boil it down to simplistic terms, because that's how I operate, I don't like using long explanations. The first output from Common Cloud Controls that we expect to see from this team of tons of different banks, institutions, vendors, individuals even are coming on and contributing. The first thing we expect to see from them is a common controls catalog that is going to include both a taxonomy to help ensure services are portable, and we're going to expect to see a threat catalog that is going to ensure that services have properly mitigated threats as is possible. The second thing that we expect to see coming out of this group is a services assessment plan, a plan for assessing services according to the common controls catalogs, which are the two above. This is going to be written in OSCAL if everything goes according to plan. This is currently en route. There's a whole working group that's dedicated towards this. If you're super excited and jazzed about OSCAL, there are people who are working on this right now, and that is an output that is ongoing. And the third thing that we expect to see downstream from common cloud controls is results from when these assessments are implemented. This is not something we expect the Common Cloud Controls project to be producing themselves, but we do expect it to be happening as those OSCAL simulated tests that they're writing are taken, ingested, implemented, performed either by a CSP or could be anybody. As those are implemented, we expect to see those results in an OSCAL format. And so when it comes to outputs, things that you can point at and read and say this is because of the CCC project, this is what we expect to see. Like I said, I'm counting on you guys having listened in previous talks. OSCAL. I should have been prepared for that question. You would think I would. So OSCAL is a... Wow! Open source control assessment language. Thank you. That's what I wanted to be able to say, and I failed. Open source control assessment language. It's a language for writing the different tests that that will then be able to map to those controls. So a lot of times when people are talking about policy as code, I'm hearing them talk about OSCAL in the same conversations. Is that a good TLDR? Do you want to add anything else? Please do, because that's not my specialty. I just know it's an output. It's from NIST. That's actually, I mean, that's a good tidbit. So flipping over to the other side here, the Compliant Financial Infrastructure Group is not new. This is something that was announced by some of the same names that you've seen talking about common cloud controls, but CFI has been around for a few years now. Like I mentioned in my opening, I've been a maintainer of CFI for a couple years, and I didn't start out as a maintainer of CFI. I came on while I was working inside Morgan Stanley, thought it was interesting, hung out long enough that they said, hey, do you want a title? And I was like, cool. They're like, it comes with responsibility. I was like, you should have told me that first. But here we are. The first thing that we expect to see as an output from CFI over the last few years is policies. There's a specific way that we have been writing policies inside the CFI group, and all of those policies are inspired by, if not directly implementing, NIST, CIS, PCI DSS. The idea is that we're taking regulatory standards that people are expected to be held to, and we are writing policies that incorporate those and branch out from them. Those policies are then passed on to our reproducible infrastructure group, which is a group that's focused on writing Terraform, writing Ansible. There's been talk of, but no engineering done on Pulumi. And so the idea is that we should be able to create infrastructure as code that adheres to the defined policies that are common among financial institutions. And then the last thing that's happening inside this particular project is runtime validation. And this is where the most code gets written. And we're going to be talking about this a little bit more in depth because we have actually built a custom solution. This is the second iteration. This is a reincarnation of a previous solution that we spent a lot of time with prior to it called Prober. Previously, we had an iteration that was very, very heavy, very robust, and could do a whole lot of different things. But we found over the years was that we didn't need to do a lot of things. We had a couple things we needed to do really, really, really well. So we made a second iteration, a whole new life from this runtime validation group, and it's called Privateer. I'm going to talk more about that. So that's why I did the most lead up to it and talk in the least detail. We're going to go into detail more about that third one here in a little bit. But that little arrow is reminding me about why we're here. We're here to talk about what we're doing between these two groups. So over the last 3 months since Common Cloud Controls was announced to the members of FINOS, and folks inside of FINOS started bringing in a lot of attention onto this and started doing a lot of brainstorming, started writing different documentation, getting all the ideas together, coming up with these three things that I wrote down and tons more, which you've seen presented all throughout the day. Over those last 3 months, we realized that some of the lessons that we've learned inside of CFI could serve as ingestion points for the outputs from Common Cloud Controls. Specifically, we've been writing our own policies, incorporating different NIST, CIS, those things. But now we realize that should Common Cloud Controls have a catalog, we should also be able to take that catalog and build infrastructure that adheres to that catalog. Then, once that's built, we should be able to pass that down and validate it to ensure that any infrastructure as code we produce is adhering to that controls catalog. And so seeing that this is just a perfect marriage for us to be able to actually do the number 2 and number 3 that are conceptual from Common Cloud Controls, where the OSCAL creates simulated tests, we are actually creating real tests. So 2 and 3 from CCC are actually done inside of number 3 on CFI, with the middle step being that we are also creating that infrastructure as code. This slide's about to get ugly because I'm going to tell you how we did that over the past few months. First up, folks from Scott Logic. Is there anybody? There's a ton of you guys at the conference. We got at least one folks. I had a whole conversation with you yesterday. You're Rob. So Rob's here from Scott Logic. The folks at Scott Logic were able to actually create the first version of a service level taxonomy adhering to the Common Cloud Controls concept. So what has been pie in the sky ideas, like, hey, this is something we should do, community members came forward and said, hey, here's what the first version, right? 0.1 of a service level taxonomy would be. And they focused on relational database management. Then, after that, JP Morgan Chase served to kind of work with us from where they've been maintaining the policy group to kind of brainstorm and help ideate and move the conversation forward on the CFI side. And on the Common Cloud Controls side, the OSCAL and the kind of conversations we had about what should be tested was driven by community members from Google Cloud. We didn't go as far as to having the assessment results because obviously that relies on tests existing, and so that's not something that got pushed forward. But Red Hat pushed forward reproducible infrastructure, so that way we would have a CI pipeline that exists in the FINOS ecosystem, deploying to the FINOS AWS service, deploying a RDS. So remember that Scott Logic helped us create a taxonomy catalog for relational database management services. AWS provides a service called RDS, which is an RDMS. So Red Hat said, hey, we can go ahead and create some infrastructure as code using Ansible, put it into a FINOS repository, do it in all the FINOS way of doing things, and I'm going to show it to you in just a second. And once it exists, then you could run some tests against it. And then our friends at Chromeware said, well, only the hard parts left. I guess we'll take it. And so I'm actually going to ask Rudy to come up in a bit and show us what he did to validate some of these things. And it's not totally complete. Just like I said, we got a v0.1 of that Common Controls catalog. We have a first early version of deploying a RDS to AWS in a CI pipeline that we control inside the FINOS ecosystem. And Chromeware has gone through and they've grabbed a few things off of that taxonomy, that service level taxonomy, and written some validation tests for it. And that's how we got here. Cool. Thank you, Slide, for telling me to step back and do this kind of high-level overview here. This is the point in the presentation where I start forgetting what my next slide is. So we're just going to hop in. Who's that surprise guest? Okay. All right. Which one do you guys want to flip over first? Left or right? Right. Right? Okay. Patches the privateer pointer. So we have a surprise guest from Patches. This is never before announced, not even, whoa, no! Oh, no! You know who the second guest is! Absolute disaster. All right, so Patches is the privateer pointer. We've just rolled out a mascot for our runtime validator. This is super exciting because we're trying to really make sure that this is an ecosystem that can thrive on its own. So that way our runtime validation working group has a home for all of those runtime validation tests. Because remember I said a minute ago that when in the previous version, the previous life of our runtime validation working group, it was very cumbersome to write new tests. Leafhouse was there for that, and it was tedious. We talked and talked and talked, and then at the end of the day we made like a few lines of code because we weren't very good at optimizing how those tests were created because we were trying to do too much. But just like a pointer dog would be proud of, we are keeping things simple. and we have the privateer ecosystem, really. So if you were to go to github.com/privateerproj up there, you'd be able to see this, which is an overview of some of the different concepts, and it'll link out to the actual code bases for privateer. It's a test harness that is plugin based, where each individual plugin is intended to validate a single service. So in this case, we're going to be spinning back and looking at how we're using privateer to validate RDS to ensure that it adheres to those controls that are defined for relational database management services. So that's our first special guest. That's so exciting. Now, you guys already know who the second guest is because I showed his picture here a second ago. We're going to pop up and invite up Rudy to talk about how he was able to implement the, you know what? You know why I didn't want to show them both at once was because Rudy's supposed to be after I show you guys the Red Hat contribution. That's why. Sorry, Rudy. I'll have you wait just a second. All right. You're reminding me of my own. Thank you. All right. Don't call me up yet. You got to give me a better segue. So, so we talked a minute ago how we have those policies, the controls that are defined by CCC, and we have from Red Hat, we have a contribution of some infrastructure as code. So they've created this, which is a set of Ansible playbooks that will create an RDS database. Pretty simple, lightweight, right? v0.1. We could accomplish the same thing in Terraform. We could accomplish the same thing in Pulumi. We don't have any contributors who have brought that up yet. Not opposed to it at all. And then we're going to delete it. The way that we're going to do that is in a pipeline, which I ran 32 minutes ago, just so that way I'm not lying to you when I say that it works. In that pipeline, I actually haven't looked at the results from this yet, so let's hope it did work. In this pipeline, we're going to deploy RDS. It's going to go into the FINOS AWS ecosystem, and it's going to pass its variables over here. And so when we say that privateer is like a armed, licensed ship that's licensed to attack enemy vessels, we are arming it with a little bit of credentials, a little bit of escalation right off the bat, so that way privateer knows where it's going and what it's supposed to be trying to do. For the case of a taxonomy, we have to do that because we need to give it permissions to actually do the different features that we expect to see from RDS. And so in this pipeline, after the code has been deployed, we are pulling privateer, we're pulling the RAID, which is the plugin that Rudy's going to show you in just a second. And then we are going to actually execute that RAID against privateer with those credentials that we passed into it. And so as we can see here in the pipeline, we are producing YAML output that is saying, it is separating the results for each different control that we're expecting. And so inside of Common Cloud Controls, we have defined that every RDMS service should be able to do automated backups. And so the team has written a couple early tests to just do some basic checks. And this will need to be more robust later on. But then we also did encryption. Like, hey, let's check and see if it's encrypted. And in this case, our infrastructure as code is deploying an RDS that does have automated backups enabled. And we've done two different steps to make sure that that's true. We've got encryption enabled. Multi-region, for some reason, is not currently working. RBAC, right? And so that's what I wanted to show you guys here before passing it off to Rudy to tell us how he created this and actually look into what it would look like to continue maintaining this over time. Before we go to Rudy, we can take a question.
Yeah, so is privateer doing a static code analysis, or is it doing it against the actual resource that's been instantiated?
This is runtime validation. So we are reading the actual deployed resource.
So what in that sense is the difference between, for example, Azure policies and audit mode or like Quiz and these cloud security posture management?
Yeah. So there's loads of different things that are available. There's two different things that stand out to me. and it might not finish your question, so please reiterate if I don't get to everything that you're wanting to explore. But the two things that stand out to me is that first, Azure policy is going to, you're going to define what it should be and then auto fix if it's out of compliance with that, right? And I think it does some alerting if something's, but largely you're defining what it should be.
Not specific policy element, which can evaluate basically characteristics of configuration of instances of a certain service. There you go.
So for anybody listening at home, Google what Azure policy is, and that's what he just said. It was a much better answer than my attempt. So what we're doing is instead of stating what it should be, we are just trying to tell you the result of when we did these things, this is what we got. In the past, I think it was about 2 years ago now, we were running this inside a major financial institution who is a member of FINOS, and we actually found specifically an Azure policy that should have done something, but when we probed it and tried to do the thing that should be impossible, we were able to do it. And so we were actually able to provide a high severity bug report to Azure, and they were able to actually improve their policies because we detected a gap that they thought was covered, but wasn't actually covered when we ran a resource and tried to do things against it. The second thing that comes to mind is that those are managed by the people who are being validated, and that's what we want to take out. And actually Google Cloud, if you saw the presentations that they've done earlier today, that's not happy. If you saw the presentations that they've done earlier today, they're actually in violent agreement that this should be cloud agnostic. So much to the point that they've resisted. Sorry, I can't see your name tag from here. Are you Google Cloud?
No, I'm not.
Okay.
But I would have argued then you would go down the route of like CSPM to like WIS, which are like cloud independent.
Yeah, cloud independent. Yep. Yeah, and so comparing this to existing resources is not something I'm able to do exhaustively right now. Would love to take it offline. But the two things that come to mind is that one, we want to actually test what is in reality, and the second one is that we want it to be cloud agnostic.
So by testing what's in reality, you're not preventing something from going bad, you're detecting that it's gone.
Yes.
Okay.
Yes. We are not preventing something that has gone bad, we are detecting it and reporting on it.
Audit trail or audit report on your...
Yeah, auditing is a great way to describe it. Yes, yeah.
So piggybacking on his question about the difference between this and the CSPMs like WIS, Orca, and Prisma, what advantage does Privateer have?
I am not currently prepared to do a comparative analysis of those. And at the end of the day, within CFI, we have at times relied on existing things such as Kubescape, right? Existing tools that are already very, very sufficient for validating a particular policy. Our working group is of the mind that if something solves the problem already and does it into fullness, then we should use that as a working group standard. But we have produced this for the gaps that exist. Oh, please.
Yeah, if I can add one thing there, which is some of these tools are looking at your estate and what's actually running for everything that's actually being used. This actually fits a lot more in, I'm making the library of modules, I'm making the library of things that is being used to build those things. And I want to know before I give people, here's a module that everybody can use for RDS, I want to test the module that does the right thing. And I want to do that before they're all deployed. So this is a different timing, a different tack that we're trying to test.
Thank you very much. That was Nick. Do you have a, Nick Williams from Morgan Stanley. Do you have a short version that you'd like me to repeat into the microphone?
What did I say? Testing of the modules that create the instances as opposed to the instances.
We are testing the modules that create the instances as opposed to the instances because we're mapping them together directly after deployment from a specific deployment strategy. We are testing the result of that deployment is a way to map, this is how I deployed it, this was the result, this is what happens when I test the result of that deployment. We can map them together to say that the way I created it is now safe. Thank you, Nick. That was actually very helpful. Rudy, we're running a little short on time, but we do have time for everything you have planned. So do you mind using my, my machine, or do you want to switch over to yours? We can use yours. Okie dokie. All right, this is Rudra Gupta from Crumware. He's part of the runtime validation group and not a professional speaker. So if you guys could welcome him, please. Thank you.
Can you hear me? Yeah. So my name is Rudra Gupta. I'm with Crumb. I'm a software engineer at Crumb. Crumb is a software services company that builds and delivers solutions using cloud-native technologies. We are based out of Columbia, South Carolina. Really excited to be here. Really excited to be given the opportunity to contribute a little something to Common Cloud Controls project. The result Eddie showed you a couple of minutes ago was carried on using this repository called RAID-RDS. This repository consists of a set of strikes. Each strike is meant to be the standard that we expect every database management system to have. For example, if I want my RDS to have automated backups enabled after my IAC is deployed, I'm gonna essentially do a raid against that hosted RDS instance using this strike. What this strike does is a strike is essentially a set of movements. Set of movements is a set of operations we have to do in order to make that strike successful. Now, for example, if we wanna check if automated backups are enabled for a particular RDS instance, obviously the very first step we have to take is to check whether that database is itself available or not. So that particular step is my movement. It's my set of operations. If I can confirm that step is working, then I can go back in and check if the automated backups are actually enabled on that instance or not. So that's one standard that we have defined as part of the strike. There are other strikes that we have defined. Those are for encryption. It checks whether the encryption is enabled on your hosted RDS instance or not. Multi-region, now with RDS, you can only have you cannot have active replication across regions. So all you can check for if you have read replicas for your primary instance hosted on 2 or more regions or not. We used Amazon's SDK service to check if the RDS that you have specified is actually multi-region or not. If they have read replicas on multiple regions or not. Then, in order to test this rate, we need an input. The way we provide an input is via a config file. Super simple config file. Right now, it expects an access key and secret key, but in the future, we are expecting it to evolve and add things like IAM database authentication, or maybe using like a session key so that we don't have to pass in access key and secret to everywhere we would run this test against. And the next minimum thing it expects is the configuration of your RDS instance itself. So right now we're dependent on instance identifier, but in the future we can figure out ARN, for example, and use that to test the deployed RDS based on your ISC configuration. Some of the future things we have to do, we have to test if your database can be vertically scalable or not. We have to test whether monitoring, enhanced monitoring and enhanced alerting is enabled on your instance or not. Because when you define your IAC configuration, you can say like, hey, when you stand up my database, turn on the enhanced configuration feature. But here we are actually testing if that feature is working or not. Those are our short-term goals, but we would love to have contributors on this project, on this repository. This repository is meant to be an exhaustive set of strikes that we can use against Amazon's RDS service. And Eddie can talk to you more about the collaboration portion of it.
Thanks, Rudy.
Yeah.
All right. And I've got just a couple more slides here to just punch through. We already met Patches, the privateer pointer. I don't want to understate how excited I was to introduce Patches to you guys. I just really want you to know that. This is the last slide. This is the takeaway. Many hands make light work. We've made the mistake in the past. One of our lessons learned is that we've had lots of people with really good ideas who are giving those ideas out to the community and hoping that someone will build something. We've got years of that. We've done a really good job with that. Over the past few months, what we've shown is that if we reach out and we actually find named contributors and we give them credit for their work, we are able to elevate people and the ecosystem at the exact same time, right? We're making sure that we're giving Red Hat credit for the work that they're doing, as much as they want to take credit for it. And the same for Chromeware, right? Chromeware is not a large organization with exhaustive engineering hours to spare, and yet they have a keen interest in elevating the financial services community, and so they've dedicated a portion of their engineering time to ensure that they are actually seeing something brought into fruition. And we can keep this going. We can continue to make the kind of progress that we've made over the past few months, and we can make it substantially faster if we continue to work together, if we can continue to bring on contributors and equip the contributors for individual tasks that we know as a community need to be done. And so we are prepared as a community to enable those contributors, to enable new maintainers to take on new privateer raids, to take on new Ansible playbooks or Terraform configurations. We, as an ecosystem, are prepared to scale quickly if engineering time is available to work on this. And so that's the call to action. The great news is that we've made amazing progress as an ecosystem through the awareness that CCC has had, the brainstorming, the mind power that has come together to make the types of things that are coming out of CCC. And now if we bring the engineering hours up too, we can do amazing things together. That's the call to action, guys. Thank you so much for hanging out. If you have any more questions, let me know. But thank you.